Welcome back to Lesson 7, where we are going to solve problems for Lesson 7. As a review, we define the slope, the derivative of the function. We take the function y of x and we find the slope as delta y divided by delta x, but it's a limiting process. It's a process where you make the limit when delta x tends to 0 of delta y divided by delta x. The rise divide by the run. The rise divided by the run when delta x tends to 0. This is the derivative of the function. We have learned on the PDF how to find the derivative of the function. We have seen this in class also. And let's go to do the problem. So the symbol to denote the derivative is f prime of x, or the derivative respect to the x of f of x. These are the same symbols, f of x, f prime of x. Okay, let's go to do the problems. We studied the power rule. The power rule say that if f of x is, the power rule say that if f of x is x to the n, f prime of x, the derivative of the function at any point x is n x n minus 1. This is the power rule. Let's go to use it in problems. So also, okay, problem 1. Oh no, this is an example. Let's go to problem. This is we saw this in class, and let's go to do the problems. So the problems say find the slope of the tangent line to the graph number 1, 3 minus 5x. So the first one say find the slope of the tangent line y or f of x equal 3 minus 5x. Y equal 3 minus 5x is a rectilinear line. It's a line with the slope minus 5 because the slope is always what it multiplied to the x, so it's minus 5. So I found the slope. But indeed what the problem says, use the definition of the slope to find the slope of this function. At the point minus 1/8, at any point the slope is the same. If it's a rectilinear line have the property that the slope never changes. It's a rectilinear line. The slope never changes. So if you walk 1 meter, if the slope is 5 and you have a rectilinear line and you stop at one point and you walk 1 meter, the height, if the slope is 5, the height will be 5. So the slope is delta y divided by delta x equal m. So if m is 5, means that delta y is 5 times delta x. So if delta x is 1 meter, delta y is 5 meters. So if you walk again another meter, the height, another meter, will be 5 meters. And what happens if you walk 2 meters? If you walk 2 meters and you are in a rectilinear line, the height will be 10 because it's been said here. Delta y is proportional to delta x. If delta x is 2, 5 by 2 will be 10, so delta y will be 10. So rectilinear line is a line that preserves the slope. The slope is always constant. If the graph do like this, it does like this. Now the slope is changing all the time. All the time is changing. Okay. Now let's go to use our definition of a slope. The definition of the slope is a limit process, is the limit of the value of the function at the point that is right to the point that we are considering. We want to find the derivative, the slope at the point x0. So this is m at the point x0. Is the value of the function at the point x0 plus delta x minus f of x0, this is delta y, divided by delta x. So a draw of this will be, this is the function, so this is the point x0, this is the value of the point, so f of x0. And you take a point that is x0 plus delta x, and you see the value of the function. And now this is f of x0 plus delta x. This is the value. So what you are doing is f of x0 minus f of x, which is this thing, the rise divided by the run. Okay. And we have to do the limit when x approach x0. When this point, or when delta x becomes 0. When delta x becomes 0, not becomes 0, when delta x approach 0, when delta x approach 0, this point is approaching the point here. And I can find the slope. Okay, let's go to do it. So it will be f of x plus delta x. F of x is 3 minus 5 of x. So what will be f of x plus delta x? It will be f of x plus delta x would be 3 minus 5 times x plus delta x. Or it will be 3 minus 5x minus 5 times delta x. What will be now f of x plus delta x minus f of x? Well, it will be 3 minus 5x minus 5 times delta x, parentheses, minus f of x. But f of x is 3 minus 5x. Now, what happened is this 3 cancel with this 3. This minus 5x cancel with plus 5x. You see, minus minus is plus. So is equal, f of x minus is equal minus 5 times delta x. So we need to find the limit when delta x approach 0 of f of x plus delta x minus f of x divided by delta x. So this is the limit when delta x approach 0. What is f of x plus delta x minus f of x? Is minus 5 times delta x divided by delta x. Equal, well, we know how to do this limit. Delta x divided by delta x is 1. So the limit will be minus 5. But this is something that we knew from the beginning, that the slope of a rectilinear line is minus 5. Let's go to the next problem. Minus 5 is the slope. You see that the slope doesn't depend on x. The slope is minus 5. So is this minus 5 is the slope at any point x, not only at the point that the problem is asking, at any point. The next problem say, find the tangent line to the graph f of x equal, Now let's go to start this problem. Find the slope of the tangent line f of x equal x squared at the point 3, 9. F of x equal x squared is a parabola, and the point 3, 9 is on the parabola, is the point 3, the height is 9. And what it's asking us is, what is the slope here? What slope is here? What is this slope? Is 1, is 2, is 3, is positive. But how much is the slope? It look bigger than 1 for sure. A slope 1 means that it's a 45-degree slope. How we can find the slope? Find the derivative. If you find the derivative, you find the slope. So we can do it using the same equation. What is the slope? The slope m will be slope m. Let me use the blue color I like more. The slope m at the point x, or f prime of x, that is the slope at the point x. F prime of x is a limiting process. It's the limit when delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. So it will be equal to the limit when delta x tends to 0. Who is f of x plus delta x? Well, f of x is x squared. What is f evaluated at the point x plus delta x? Well, substitute the x by x plus delta x. And f of x plus delta x is x plus delta x squared. So if I plug in my information here on the limit, will be x plus delta x squared minus f of x. Minus f of x, that is x squared divided by delta x. If I do a little bit of algebra, it will be the limit when delta x approach 0. If you do x plus delta x squared, will be x squared, square of the first, plus square of the second, plus 2 times the first by the second delta x, minus x squared divided by delta x. So this limit will be the limit when delta x approach 0 of what? X squared is cancelled with this. So it will be 2 times x delta x plus delta x squared, divide everything by delta x. But as you know, you can split this in 2 parts. The first part will be 2x delta x divided by delta x plus delta x squared divided by delta x. So now this limit, when delta x approach 0, this limit is delta x divided by delta x is 1. So its limit is the first limit will be 2x, and the second limit is the limit of delta x squared divided by delta x, which is delta x. And the limit when delta x tends to 0 is this goes to 0. So this goes to 0. So as a final conclusion, the derivative is 2x. So f prime of x, or the slope at any point x of the function f of x equal x squared, is 2x. But the problem is asking us at a particular point, at the point 3, 9. Well, at the point x equal 3, if x equal 3, f prime of x, the derivative of the slope is 2 times 3, which is 6. So the slope is 6 at the point x equal 3. You can do the problem also using another definition that is very similar, that of the derivative, and the definition will say the following thing. The slope, or the derivative, will be a limit process. Instead of using delta x, you use the point c as 3. And you say that the point x is here. So f of x, you see, the rise the rise here divided by the rank. So this is x and this is c. This is the point c, that in our case is 3. So we will do this limit like f of x minus f of 3 divided by delta x, which is x minus c. This is x, and this is c. And x minus c is this, and now the limit will be when x approaches c, or when x approaches 3. If you do it in this way, you will find the same result. F of x, x squared, f of c, 9. X minus c, x minus 3. So it's the limit when x approaches 3, when this x approaches 3 of the slope of the rise divided by the rank. But you know how to do this limit. You factor in this way. X minus 3 will cancel and will be x plus 3. So the limit will be 6. This expression, f prime of x equal to x, is a more useful expression because it gives you the slope at any point. At any point. At x equal 4, the slope is 8, 2 by 4. So the way that we did is maybe more practical. Let's go to the next problem. The next problem says, find the derivative of f of x equals 7. So the function f of x equals 7 is a constant function. And a constant function doesn't change. It's always 7, 7, 7, 7. So there is no change. This will say that if you choose the point x here and the point x plus delta x here, f of x will be 7, and f of x plus delta x will be 7. So f of x minus, if I'm going to find the derivative, the slope, I will need I will have in the numerator a 0. So 0 divided by something that is different than 0, because delta x is different than 0. Delta x approaches 0. 0 divided by delta x, when delta x approaches 0, this is 0. This is 0, so the slope of a horizontal function is 0. So this is 0, 0. For any delta x that you take, 0 divided by delta x is 0 always. So the slope of a horizontal line is 0. Let's go to the next problem. The next problem is trying to repeat again the same process. Find the derivative. Well, the derivative is the slope, so it should be 3. For any x, it should be 3. So we do again the same process. We find f of x plus delta x minus f of x. F of x minus, so f of x plus delta x is when you plug in instead of x, you plug in x plus delta x. So it will be 3 times x plus delta x plus 2 minus f of x, 3x plus 2 plus 2. So when you do the algebra, divide by delta x. When you do the algebra will say the expected value. The slope of a rectilinear line is the coefficient that is multiplied by the x, that is the 3. So we check again our definition. Let's go again. Now let's go to do something a little bit more complicated. What we will find here, that if you write x1 divided by x squared like x minus 2, the derivative respect to the x of 1 divided by x squared or x minus 2 is equal minus 2 x minus 2 minus 1 minus 3. And this is the derivative. The derivative of x to the n is, this is the function, and this is the derivative is nx to the n minus 1. So Let's go to check it with this function, 1 divided by x squared. 1 divided by x squared. So we apply our definition of the derivative. The derivative is the value of the function evaluated at the near point x plus delta x, very near to the x, separated by the distance delta x. So f of x plus delta x minus f of x divided by delta x is the slope. Who is f of x plus delta x? Instead of writing x, write x plus delta x. So it will be 1 divided by x plus delta x squared. Minus f of x. F of x is 1 divided by x squared. So it's minus 1 divided by delta x. Do a little bit of algebra and you will find, if you do a little bit of algebra, not difficult algebra, you will arrive to this expression, minus 2x delta x minus delta x squared divided by all this expression. Now, if you divide by delta x the numerator and the denominator, so this delta x will disappear, this delta x will disappear, and this delta x squared will disappear, and will appear only delta x if I divide numerator and denominator by delta x. So it will be the limit when delta x tends to 0, when the point approaches the point x. Of minus 2x minus delta x divided by x squared, x plus delta x squared. Now when x approaches 0, this limit can be done like this. When x approaches 0, when delta x approaches 0, delta x approaches 0, the numerator approaches minus 2x. And when delta x approaches 0, x plus delta x approach x, so it will appear x squared. X squared, So in the denominator, I will have x4. So I will have minus 2x cubed. And now x divided by x4 is x cubed in the denominator. So equal minus 2x minus 3. So the derivative of x minus 2 is, this is the function, and this is the derivative, minus 2x raised to the power that exists, that is minus 2 minus 1. Minus 2 minus 1 minus 3. So this is the derivative, and this is the rule. We don't have to do all the time the limits. We just check that the limit work. So you need to learn the power rule. Say, if f of x is x to the n, the derivative is n x n minus 1. F of x, f prime of x. The slope. Okay? Okay, let's go to the next problem. The next problem say like this is using the same definition. Find the equation of the tangent line to the graph square root of x at the point 1, 1. Square root of x does like this. When x equal 1 is 1. So this height is 1. And the graph does like this. It has an infinity slope at x equals 0 and does like this. And the challenge problem here is to know what is the slope here. What is the slope at the point 1, 1? This slope. This slope looks to be less than 1. Less than 45 degrees. Slope 1 means a 45 degree because slope 1 m equal 1 means delta y divided by delta x means that you walk 1 meter, delta y is 1 times delta x, means that you walk 1 meter and you go up 1 meter. So in this way, delta y equal delta x. This is in general, delta y is m times delta x. This is the idea of the slope. So let's go to do it, or please see how is the same process again. Is the same process, f of x plus delta x minus f of x divided by delta x. The point x is the point 1 because they want to find the slope at the point 1, so f of 1. So you do the calculations and you will obtain the slope, and the slope, it will be, if you do the calculation, it's long. Why so long? 1/2. The slope is 1/2. Let me see if I can do the calculation more faster than this. So I have to do this limit, square root of 1 plus delta x minus the square root of 1, that is f of 1 plus delta x minus f of 1 divided by delta x. Well, here I multiply by the conjugate of the numerator. I do the algebra and I obtain this expression. No, it's short. No, it's not so long. I obtain this expression. Now delta x cancel with delta x. Delta x cancel with delta x. And when delta x approaches to 0, this term approaches to square root of 1. Because delta x approaches to 0. So it will be square root of 1 with this 1 plus 1. It will be 2. So it will be 1/2 the slope. We can do it in general way with the x not fix at x equal 1, any x. So we use this equation, the definition of the slope. Well, the h is the same that delta x. So wherever you see h, you write delta x and it's the same. So if delta x goes to 0, h goes to 0 also. So we can use this definition that is in many books. The advantage of this definition is that instead of writing h, instead of writing delta x here, you write h. So it's more convenient to write less thing, no? So if we do the general, if we try to find the derivative of any point of the function square root of x, we have to do this. F of x plus h, or f of x plus delta x, if you prefer, minus f of x divided by h, or divided by delta x, if you prefer. And the limit is when h approaches 0, or if you prefer, when delta x approaches 0. I did it here with the h, I don't know why. Well, it will be f of x plus h, f of x, f evaluated at the point x plus h, square root of x plus h. F of x is square root of x divided by h. So I did this limit, and I found a general, I did this limit in the same way that we did it before, and I found that f prime of x is 1 divided by 1/2, 1 divided by 2 square root of x. So this is the power of the limiting process of finding the slope at any point x. If x is 3, or let's say it's x is 9, square root of 9 is 3, and the slope, if x is 3, the slope would be 1 divided by 2, if x is 9, 1 divided by square root of 9, square root of 9 is 3, 1, 6. So as you progress, as you run in the x direction, the slope is coming smaller and smaller. So, but the problem is asking, what is the tangent line at the point 1, 1? At the point 1, 1, we saw that the slope is 1/2. Is 1/2. Let me check here. The slope is 1/2 at the point. Let me check here also. If I plug in here, this is the slope, the equation of the slope. If applying x equal 1, 1 divided by 2 square root of x, will be 1 divided by 2 square root of 1 will be 1/2. So the slope at the point, I have the graph, I have the point 1, 1, 1 is square root of 1, which is 1. And I have the slope. And the slope is 1/2. And what is this tangent line? The equation of a rectilinear line that passes through the point 1, 1, 1, 1, this point, and has a slope 1/2 is y equal y0 plus m multiplied by x minus x0. Let's go to plug in number. Y equal y0. Y0 is a square root of 1, which is 1. M, the slope here is 1/2. 1/2. X minus 1 minus x0. X is 1. X0 is 1. So it would be 1 plus 1/2 x minus 1. If I do a little bit of algebra, it will be 1/2 of x, 1/2 of x, plus 1/2. It will be minus 1/2 here. 1 minus 1/2 will be 1/2. And this is the result of what they are asking me to find. This is this rectilinear line. Okay, 1/2 of x plus 1/2. Okay, let's go to the next problem. The next problem is determine whether or not the function x plus 7 is differentiable everywhere. Is differentiable, the result, the answer is differentiable everywhere, except at the point x equal minus 7. At this point, for example, the slope is minus 1. At this point, the slope is plus 1. So the slope does like this. This is the point minus 7. At the right of minus 7, the slope is plus 1. At the left of 7 minus, at the left of 7, the slope is minus 1. And what happened at 7? At 7 doesn't exist the derivative, because the limit, when you go to the right, the limit is plus 1. When you run to the point minus 7, when you approach to the point minus 7, the derivative is minus 1. So we say that there is not a definite, defined derivative at the point x equal minus 7, then the function is not differentiable at x equal minus 7, but it is differentiable at any other point. Okay, let's go to the next problem. Next problem say, determine whether the function x minus 6 2/3 is differentiable at any point. Well, I will do the derivative. We can do the derivative more easy. X minus what? Minus 6 2/3. X minus 6 2/3. F of x. What is f prime of x? What is the slope at any point x? What is the derivative of f in respect to the x? Everything is the same thing, what I say. The derivative, we apply the power rule. And the power rule says that this is 2/3 x minus 6 raised to the power 2/3 minus 1. 2/3 minus 1, 1 is 3 divided by 3. So 2/3 minus 3/3 is minus 1/3. Minus 1/3. So we write this like 2/3 multiplied by x minus 6, 1/3. Okay, and now what happened with the derivative? If x equals 1, the derivative f prime at the point 1, the slope of this function at the point x equal 1, the slope at x equal 1, so this is the function. I'll go here, and the slope should be negative, you see? The slope here at x equal 1, let me put it at 0.1 here. Okay, or at x equal 2, let's say. At x equal 2, the slope is negative. And here it says what is the value of the slope. The value of the slope, if x is equal to the value of the slope, f prime evaluated at the point 2. At the point x equal to, the value of the slope at the point x equal to is 2 divided by 3 multiplied by 2 minus 6 is minus 4. So it's the cubic root of minus 4. And the cubic root of minus 4 is a negative number. So this is negative. The slope is negative. So is differentiable this function or not differentiable? As you see, is differentiable everywhere except where. At what point is not differentiable? If I plug in x equals 6 here, will be 2 divided by 0, and it will not exist the derivative. It will be an infinite derivative. It will not go to a fixed number, and so this function is differentiable everywhere except at the point x equals 6 when it has a vertical slope. It has an infinity slope, so the derivative doesn't exist. Okay, let's go to the next problem. The next problem says, given the graph of f, sketch the graph of f prime of x. Okay, if they give me this graph, I will do like this. This is a rectilinear line. What is the slope? I can find the slope. I see minus 4 here, so everything here is 4. So delta y is 4, and delta x is 4. And both of them are positive, so the slope is 4 divided by 4, so y equal 1. So m equal 1, the slope is 1. So this graph, and any graph parallel to this graph, any one, will have a slope 1. Anyone will have a slope 1, a slope 1. Okay, so what is the graph? Well, this is the graph, it's a slope 1. This is f prime of x. For all x, the slope is 1, 1, 1, 1, 1. At 0, 1. You see the slope at any point of the rectilinear line is 1. So the slope exists and is 1 at any point. Given the graph this one, sketch the graph of f prime of x. So it will be like this, the graph. At the right of the point 4, the slope is minus 1. So it will be like this, minus 1 all the time because it's a rectilinear line, minus 1. At the left. At the right, it is plus 1. So this is 1, is plus 1. So the slope is plus 1 at the right, minus 1 at the left. And at the point 4 doesn't exist, because if you make the limit, when you approach 4, for the right, the limit, the derivative here, will be plus 1. And if you approach through this to the left, to 4 minus, it will be minus 1. Okay, we are finished. This kind of problems, newspaper circulation, that are application of these two problems in business, this we'll do in another video, not to make this video so long. Okay, I'll see you soon. Good luck. Let me show you all the problems. 59, this problem 60, 61, 62, and that's all.